Great. So, yeah, I thought I'd come along and just give a bit of talk about some of the testing that we've done as part of the development of Erasure coding. So you heard about that from the development of Erasure coding itself from Alex and Bill earlier, and some of the other stuff. Yeah. So how did we test the optimizations we did for Erasure coding? So we did some unit tests, added our own unit testing. We have put it through Toothology with the optimizations enabled, with them disabled. We've done performance testing, making sure we see the sort of numbers we're expecting to see. And we also developed a new tool, the Ceph IO sequence exerciser, which is the tool that I was hoping to talk to everyone about today. So why did we want to create a new tool for testing? Well, Erasure coding has some particular properties to it. It's got specific shard size, you've got K, M values, things like that. And we wanted to be able to sort of stress those different properties and boundary cases of Erasure coding in our testing using this tool. So, for example, I've got a picture down here of three disks, three shards. Knowing these properties allows us to test a full stripe across all those shards. There are other interesting use cases we can do as part of testing this. So we might want to test writes which are not of a full shard length, writes that don't include all the shards. So we've got right here that is across two stripes, but not including those shards. We've got writes that cross stripe boundaries and writes that cross shard boundaries. And we also want to test things such as multiple overlapping writes, where we send a write into the system, and before it's processed, we send another write into the system, and we want to make sure that those are processed in the correct order. So those are some of the things we want to make sure are behaving correctly as part of Erasure coding. We want to make sure that's part. So we had a couple of aims while developing that. One of the aims was to stress those things we just talked about, make sure it can deal with all the tricky scenarios. One of the other aims is we wanted to have some very varied tests to make sure we're not just testing the same thing over and over and over, but also ability to reproduce them like for like if we want to debug something that's of interest or replay something of interest. So now it'll be quite interesting, I feel like, to give you a bit of insight into how this tool works. So I've split it into three sections: how we do the data generation, how we do testing of unfavorable scenarios when you've got errors in your system, and how we do the sequence generation. So in terms of data generation, we generate data in blocks. So these blocks could be something that you specify as a user, or they might come from a predetermined list of interesting values. These could be based on a divisor of the chunk size, or explicitly not a divisor of the chunk size, just to give you some interesting coverage of overlapping shard boundaries and having missing shards and things. These chunks have headers in them with some interesting information, such as the application ID, so that we can make sure that the data that we're reading is something that we've written from this application, or if it was from somewhere else, in which case we might want to investigate where that came from. We also put in a seed and a time, which is quite useful for debugging. You might want to know when the data that you're looking at was written, and for that we can see it from the header. And the final thing that's quite interesting is when we do a write of data using this test tool, we save that seed into a model we keep in memory. When we read that data back, we can look at the seed that we used to generate it, regenerate that data like for like, and compare what we've read from the system with what we would have tried to read from the system, and ensure that they are identical to make sure things are you're reading what you wrote, essentially. The next section of the tool I'd like to talk about is we test injecting errors into the tool. So this might be having the tool think it's got a missing shard so that we can see how it deals with reading from parities. We might inject a write error so that we see how the tool deals with, we see how Ceph deals with rolling back shards in the new optimized Erasure encoding and making sure it all gets rolled back correctly across all the shards. Finally, the last interesting bit of the tool I'd like to talk about is our sequence generation. So this allows us to control the order of the IOs that we send to the system. So it's not just single IOs that are interesting, but it's different orders of IOs as well, testing different things. The generators let us control many things, the operation type we're doing, offsets and lengths, and a few other different things. So I've got a couple of examples of some of the different sequences that we run through this tool. So this first sequence I've got, what it does is it does a write of 3 different ranges, and then it will read the entire object back. We will go through many different variations, moving around where those different ranges are, introducing gaps between them. So those gaps will then land on shard boundaries. They will miss entire shards as the gaps get bigger. They will not necessarily start at the beginning. We also vary the size of the objects we're testing on throughout this. So we'll test various different sizes of objects, and we will do hundreds, thousands of IOs as part of these sequences. So we'll get a lot of testing of interesting IOs as part of this. After every IO, we do a read, and this just makes sure that even with any of these different operations where we do 3 read IOs in a single transaction, we will read it back and get what we're expecting. The next sequence, which is quite interesting to talk about, is our error inject sequence. So we will create an object, we'll inject an error into it to tell it, pretend you're having a write issue. We'll then write to that shard that's having an issue. It will then roll it back, and we will read it and make sure that the data has been read back. We'll then clear the inject, do the write again, and make sure that it's successfully written this time. And we will move this block around the system and test this for various different parts as part of this sequence. Final sequence, which is quite interesting to talk about, is our append sequence. So as part of this, we create an object. We then do a write off the end of the object so that there is a gap between the end of the object and the start of the write. And we'll do this a few times, and then we'll read the entire object and make sure, once again, that what we read back is what we're expecting to have been written in the system. As part of this, we will vary the size of the gap, we'll vary the size of the object, we'll go through many different iterations, make sure everything is being read as expected. Again, doing hundreds, thousands of operations as part of this. So there's a few other additional features which are quite useful in this tool. So we've got threads, which allows you to specify how many IOs you're doing to a single object at the same time. We've got parallel, which lets you control how many objects you want to write to in parallel as part of this at the same time. We've got pool, so you can predefine a pool rather than having the program generate it for you. We've got verbose, which is quite interesting if you're developing, or just if you want to learn how the tool works. It'll output each IO as it goes through, tell you what that IO is doing. And the last one that's quite useful that we've used is interactive. So interactive is different to what we talked about before. So before we were doing sequences of operations that were automatically generated. Interactive mode lets you control the order of the operations you're doing with any of these different commands. It's quite useful if you want to go in and do a specific couple of precise order of things. Very useful for testing small things when you're developing. So yeah, the tool, there's still more work that can be done. It's not necessarily finished. There's future work still to do. So the top one, integration to run as part of Toothology, is sort of the one I'm most interested in getting in next sooner rather than later. But if anyone's interested in seeing the code as it stands at the moment, I've put links to where it is in GitHub, or you can contact me at my email down there if you have any questions or interested in getting involved. I'll be quite happy to have a chat. But yeah, that was that's it really. That's everything. I thought it would be interesting to sort of give an insight into some of the testing we did, and I hope it was quite interesting for you all to hear. So yes, thank you very much.